Torreira. Greetings of the day, dear students. In this video, we are going to discuss about the components of transmission line. What are the different components we are having, dear students, like conductors, step up, step down transformer, insulators, supports, and some protective devices like lightning arresters, right, ground wires, circuit breakers, relays, and also about the voltage regulating devices. So we will also show you some physical components, how they will look like transmission towers, transformer, and insulators, supporting towers, lightning arresters, SF6 circuit breakers, and voltage regulators. All those things we are going to discuss in this video. Dear students, in the previous videos we have discussed about the power generation, how it is to be generated and how it is to be transmitted or distributed in the previous videos. Now, with respect to the transmission line, where the bulk amount of power will be transmitted over long distances with the help of transmission lines, where it will be most of the times three-phase, three-wire system, three-phase, three-wire system. Now, in order to do so or achieve or transmit the power, we require the conductors. The power will be transmitted through the electrical conductors. Now, those conductors will be made up of, most of the times the material used is aluminium, or which will be reinforced with steel. If it is a single circuit, generally we will be having 3 conductors for a single circuit line, and if it is a double circuit line, we will be having some 6 conductors in a double circuit line. It looks like this. For example, you might have seen while traveling to different places at the outskirts of the cities, or while traveling in railways or through road means, you will be observing these towers. This is a single circuit tower where you are having only 3 conductors. You can observe phase A, phase B, and phase C, or R phase, Y phase, and B phase, RYB. Right? This is a single circuit tower, single circuit line. But whereas you can observe such kind of towers also, where this is called a double circuit, where you will be having 6 conductors, right? Yeah. Next one is the transformer. Its major purpose is to step up the voltage or step down the voltage without any change in frequency. It does not mean that if the input supply frequency is 50 Hz, there won't be any change in frequency, but the levels of voltages will be changed. Depending upon the step up or step down voltages. For example, primary side and secondary side we will be having, right, and we can step up or step down the voltages in order to transmit the power at higher efficiency levels. You can observe this is the power transformer, where it will be having the primary and secondary, right, and we can step up or step down the voltages. Next one is the line insulators. Now these electrical conducting conductors are to be supported with the help of insulators. They act like a support for the conductors, and these conductors will get isolated from the ground with the help of this line insulators, which will be made up of mostly porcelain, right? Here these are the insulators. Depending upon the ratings of the voltages, whether it is 130 400 kV or 220 kV, 400 kV voltage levels, or 220 kV, 132 kV, 66 kV, or 33 kV, or 11 kV, or 440 volts, right? Depending upon the voltage level, it has to carry or it has to withstand the insulators are to be selected. Of course, in India we are also having 765 kV level transmission towers also we are having, right? So depending upon the voltage level the insulators are to be selected. Now these insulators insulators are going to support the conductors, which are going to isolate the conductors from the ground. Next one is the supporting towers. Depending upon its power carrying capacity, voltage ratings, the towers will be laid. Supporting towers or structures we can observe, right? And here on the over the transmission lines or towers, if huge clouds are formed, now these clouds are going to discharge. These are nothing but massively heavily charged bodies at the bottom of the clouds. They are nothing but the heavily charged bodies. They will always be searching for the sharp object to get discharge, which leads to the lightning stroke. Once if there occurs a lightning stroke, these lines may get damaged. So these lightning arresters are going to protect the transmission lines, and which acts like a surge arresters. The lines will be protected from the lightning strokes. They provide the deep discharge path for the lightning stroke to get discharge instead of resulting in a heavy short circuit currents. Similarly, to make the circuit or break the circuit, just like a switch, for example, a switch, with the help of a switch control, if there is a source here and if you are having a load here, with the help of switch we can make the circuit or break the circuit. Similarly, electrically, when the huge amount of power is being transmitted, to make the circuit or to break the circuit, or during fault conditions or abnormal conditions, for protection purpose, these circuit breakers will come into the picture. These are the circuit breakers. Of course, different types of circuit breakers also we are having: oil filled circuit breakers, vacuum circuit breakers, SF6 oil filled, vacuum circuit breakers. Like that we are having different types of circuit breakers to make the circuit or break the circuits, or to isolate the electrical circuits during abnormal condition, or sometimes during healthy conditions also, for maintenance of the lines, to isolate the power from the lines, right? These circuit breakers will be useful, right? Yeah, for switching purpose. And also once the power is being transmitted over long distances and bulk distances, as I told in the previous videos, it does not mean that if you are sending some 132 kV, after power being transmitted over some around some 180 kilometers or some 90 kilometers distance, at receiving end also we should get some 132 kV, but practically there will be voltage drop in the voltage drop we can observe, right? But it is very important to maintain the receiving end. Also the rated voltage is to be maintained. In order to maintain that, some voltage regulators are required. For that sake, we will be using the voltage regulators. This is the pictures of the voltage regulators. Like this, we are having different components: voltage regulators to regulate the voltage, circuit breakers, lightning arresters or surge arresters, towers, insulators, power transformers, and single circuit, double circuit lines. So these are all the different components of the transmission line, right? Yeah. Of course, dear students, it is not there for your syllabus, I think. With respect to the electrical engineering, while discussing the transmission lines, the lines itself will be having, even though this is nothing but the conductor only, right? These are nothing but the conductors only. For example, 3 conductors, some spacing will be there between R, Y, B, and the line itself is going to have some resistance, and because of the current flowing, high magnitude of current, some flux will be established, and because of this flux some inductance effects will be there. If you observe, this is a current carrying conductor and this is also a current carrying conductor. In between these two conductors, air is there, which acts like a dielectric insulator, dielectric. Now indirectly it is acting like a capacitor. It is acting like a capacitor. So if you want to represent the line, transmission line, in its equivalent Of course, here we are having a huge tower. These lines will be going on. So while representing its equivalent circuit representation, depending upon the type of the network, T network or pi network, they will be realized in the form of this line in terms of electrical equivalent in the form of diagrams. To represent the transmission line, we cannot draw a line. For example, dear students, if you are having a source, I cannot draw here an entire generator. Electrical equivalent symbol I will use for this example. This is generator. Now a huge transmission line, and after that a huge transmission line. After long distance there is some load. So electrical people can understand this diagram. But while representing this line, if it depending upon the T network or pi network, they will be having some resistance and reactance of the line. This entire, depending upon its entire length, a single value of resistor and reactance will be represented, and in shunt they will represent the capacitance. Again they will represent the resistance and reactance. It does not mean that really there are resistors, inductors and capacitors in the line. Its effects can be observed. So RT, resistance of the transmission line, inductance of the transmission line, and capacitance of the transmission line, like this. This is the sending end and this is the receiving end. If it is this is in the form of T. For example, if you are using pi network, lot of analysis can be done on this resistance, inductance and capacitance of the transmission lines, right? If it is a pi network, you can observe resistance and reactance will be there, and in shunt you can observe the capacitance of the line. So this represents the pi network. So this is the resistance of the transmission line, inductance of the transmission line, and capacitance of the transmission line. Capacitance of the transmission line. So these are the resistance, inductance and capacitances, and so many other parameters will come into picture, whether they are transposed or not, symmetrical, unsymmetrical, bundled conductors, clearance to the ground with respect to the at what height it is there with respect to the ground, and distance between each two conductors, distance from the ground, and so many parameters will affect the resistance, inductance and capacitance of transmission lines, right? Of course this is not there for you, just for your understanding sake. The lines will be equivalently represented like this. But with respect to the components, what are the different components are present? These are the some of the major components, right? Conductors, step up, step down transformer, line insulators, supporting, protective devices and voltage regulating devices. Thank you.